So guys, this is a snake. Snake.
This here is the head. As you know, don't let it bite you. And then from here down to here is the trunk. And then we've got the cloaca, which is used for excretory systems such as reproductive and excreting different things. And then down here is the tail.
Alright, so here's the internals of the snake. You'll start with the skin, and then you have with the body cavity. They're held together by a connective tissue. Usually here in mammals and such, you have adipose tissue that develops here for fat storage, versus in the snake, they're all down here in these little orange pieces called fat bodies. That's where they store their fat. You have an esophagus and a trachea, just like you see in mammals. The esophagus is going to be what carries food. It's the larger of the two because snakes like to swallow their food whole because they don't have very good manners. And then you have the trachea here. Up here, not visible behind this, is going to be the pharynx and the larynx. The larynx is the voice box, but since it's small and very underdeveloped, that's why all they can do is hiss, because all they're doing is pushing air through it. And then the pharynx just connects the two. You follow that down and you'll hit the heart and the lungs. In snakes, they have two lungs, just like in mammals. However, one of them is non-functional. Usually the left lung is the one that's non-functional because the snake is everything's so tightly compacted in here. Having two lungs would be impractical. So you have a smaller left lung that's not visible behind this, and then you have this larger right lung. Works similar to a mammalian lung with alveoli and bronchioles and capillaries, etc. And then you have the heart here. It is a 3-chambered heart with 2 atria and 1 ventricle. It's not a 4-chambered heart like we have. Its primary responsibility is gas exchange along with the lungs to help get the carbon dioxide out and the oxygen in. Okay, so this is the esophagus, also known as the esophagus in Hunter's group anatomy terms. And it's fairly large, seeing as how snakes like to eat their prey whole. They don't like to chew because they're rude like that. Again, they're just rude. So this esophagus follows down through the body cavity, eventually reaching the stomach, which is smaller than you'd expect it to be. What happens in the stomach is just like what happens in mammals, is that you have acids that start to break down everything and turn it into a kind of a liquefied state, where they pass through the pyloric sphincter and into the duodenum, which is the first part of the intestines. In the duodenum, the liver secretes bile salts that help to break down what's left of the food in there, such as the fats and the carbohydrates, which are then stored in these fat bodies for later use. Once it passes through the duodenum, it goes into the intestines, which the duodenum is part of the intestines, but it's the first part.
Visible earlier, the gallbladder stores the bile, which then secretes into the intestines.
The intestines, just like the rest of the organs, are elongated so that they can fit in the snake's really long and slender form, whereas in mammals you see them kind of do this number while being coiled. In snakes they just go straight down because the snake is an elongated animal. So as you follow the intestines down, eventually you're going to reach the rectum, which when we think of rectums in humans, we don't think of a tube, we think of the exit. So it follows down, it kind of straightens out, as you can see here. And all of these tubes, the ureters, the gonads, rectum, all lead out to this cloaca right here, which is the excretory orifice of the snake, used for reproduction, used for nitrogenous waste disposal, and used for solid waste disposal if there's any left.
Next, we have the testes, which flows to the vas deferens. We have 2 testes and 2 vas deferens. Testes produce sperm. Then we move down to our vas deferens, which unlike in mammals, it flows all the way to the cloaca instead of the urethra in mammals. We have our left and our right kidney, which is the excretion and the substances such as iron and water and nitrogenous wastes.
Snakes use their eyes for deciphering visual images. They do not have eyelids, so their eyes are never closed, which makes it very hard to sneak up on a snake. Though the snake has no ears, he can hear through his environment by detecting low-frequency vibrations. The snake uses his sense of taste and smell in order to sense what is in his environment. He uses his tongue by flickering it back and forth in the environment in order to activate these chemoreceptors. The organ called the Jacobson's organ is the primary structure responsible for identifying scents. The tongue draws the odor particles from the air and activates the Jacobson's organ. This is located at the roof of the mouth. The epithelial tissue within the Jacobson's organ contains many nerves that transmit olfactory information to the brain for identification.
Here we have a generalized reptilian brain. Numbers 1 and 2 are your olfactory sac and your olfactory lobe, which are responsible for the sense of smell. Reptiles rely heavily on their sense of smell because their vision and hearing aren't too good. Next we have the number 3, which is the cerebral hemisphere, or the cerebrum, responsible for processing all the sensory information that comes in, including the smell, the vision, the hearing, etc. Then on number 7 we have the medulla, which is the extension of the spinal cord into the skull, responsible for all the autonomic nervous systems that don't need to be controlled consciously. And then in the center, we have the pituitary body and the infundibulum, which are responsible for all the release of the endocrine hormones, such as adrenaline when the snake is excited and kicks in and needs to capture its prey. The snake also has number 4, which is going to be the optic chiasma, which is the joining of the two nerves, the two optic nerves coming from the eyes. As you can see, this portion isn't nearly as large as the olfactory sac and the olfactory lobe, because the snake relies more heavily on its sense of smell rather than on its sense of sight. Action. Okay, tell me when you're ready.
I'm ready.
Okay.
Go. Ready.
Okay. The intestines are elongated, just like. Hi, Mom. So absorption. Again, they're long. Body cavity.
Okay, so the close back.
Because the rest of the organs are elongated as well. I sound like Yoda now, so try or do or do not. There is no try. Some behind the scenes, guys. He's not too happy about this.
Okay, in the snake.
It's a long, nice piece of muscle that they use to whip their tail back and forth and whip their tail back and forth. And that's
These are called the vast.
how you're taking a picture. Yeah, I feel like an idiot now. Thanks, Faith. See the urethra here.
Instead, in nuclear liquid. Okay, that was not.
Okay, go for it.
Say, snake brain.
Tell us about the snake brain.
Snake brain was huge.
Snake brain was huge.
Yes.
What does the snake brain have in it?
It has its brain right here.
And what does its brain do?
It just has so much energy to do.
Okay.